Hello guys, welcome to Cloud Guru channel. In today's video, we're going to talk about how we can implement an IPSec tunnel between an on-prem location and AWS. In our demo, we are going to demonstrate the basic concept of the IPSec tunnel and what we can use to implement an IPSec tunnel between the AWS environment and an on-prem location. So let's go quickly into the architecture diagram. As you can see in the architecture diagram of our demo, we have on the right hand side an on-prem location. We have a Linux. Basically, in this lab, I'm going to demonstrate through a home environment as a on-prem location, but essentially it could be office location or inside location as well. So as you can see on the right hand side, we have an on-prem location. We have a router which is actually providing the public IP for the IPsec tunnel configuration, and the left hand side we have a AWS VPC environment. In the AWS side, we have a VPC of 10.1.0.0/16. We have two VMs, EC2 VMs. One VM is going to run some additional software, which, as you can see on the left hand side of the tunnel, is called StrongSwan. And when we're going to provision this, we have to make sure that it gets a public IP, either using the provisioning method of the AWS EC2 instance, or we can use Elastic IP as a public IP for this EC2 instance. On the leftmost, you see a database instance that will actually show you that how we can, once this VPN establishes, once the VPN tunnel is established, we can always reach from the on-prem location to any other VM or any other EC2 instance which is sitting within the VPC by having some additional routing. So let's go and jump into our demo very quickly. So let's go as you can see here, I'm going to create a VPC first. So let's go to VPC only. I'll call it test VPC, for example, in this case. And we have the IP address of 10.1.0.0/16. And I don't require an IP version 6. And that's it. Let's create the VPC first. The next step is create the subnets. Let's create subnets in our VPC. So first subnet we are going to create, I'll call it database subnet. That's our DB2 instance, database instance will sit. So database DB subnet. And availability zone, I don't have any preference right now. And the subnet IP address would be 10.1.1.2.0/24. Okay, and just say create the subnet. Now this is our DB subnet. Now to host the StrongSwan, we have to understand that this design which we saw here on our diagram, we are using an EC2 instance to be configured as a VPN endpoint of our tunnel. But essentially, we can have a VPN gateway as well instead of running an EC2 instance. Right now, we are doing this lab with the EC2 instance running an additional VPN software, StrongSwan. We can also use OpenSwan. We can use some other software as well to make sure that we can, configure the tunnel with the help of this software. But essentially, this subnet, which is hosting this StrongSwan EC2 instance, has to have a public connectivity because it needs to talk to our on-prem location. So to configure the public subnet, we create a subnet called, let's say we can call it gateway subnet, or we can say StrongSwan subnet, whatever you call it. Let's say we call it we call it gateway subnet. Okay, and then IP address would be 10.1.1.0/24. Okay, so we're getting this subnet. Let's create the subnet. Now once the subnet is created, we have to do an edit here. We have to enable the auto assign public IP address, as you can see here, and let's enable the DNS routing as well, and let's use the resource name as a source for the DNS. But creating or enabling the public IP or automatic public IP assignment on a subnet in AWS does not mean that you can reach out to internet directly. For reaching out the internet, you have to do an internet gateway creation. So let's create the internet gateway creation. I can call it test IGW internet gateway. Create the internet gateway first. Then we have to attach it to the VPC, which is test VPC in our case. So let's attach it. Then we have to go to the route table. We create a route table first. We can call it route to internet, and we will select to test VPC. So this is the route table creation. So once the route table is created, let's edit the route creation, edit the routes, add a route, and we will say going back to the internet, use the internet gateway which we have created, and then save changes. Then we have to go to the subnets, and our subnet is this gateway subnet. That's what we want to give the internet access. So here we will associate, basically you can assign the route table to it. As you can see, you can assign the route to the internet, or that's route table, as you can assign the route table, this internet route, to our subnet gateway subnet. Now by that time, by doing this route table creation and assigning, so basically we have created internet gateway first, and then we actually created a route table which says, okay, my route to the internet has to go through the internet gateway. So those two steps are done, and then we assign this route table to our subnet which requires the internet connectivity. Now at this stage, if we deploy a VM or a EC2 instance in gateway subnet, it will have a route to the internet and should be able to access the internet basically. So let's go and create our first EC2 instance. Let's go for EC2 instance, and I call it launch. I'll call it or I can say StrongSwan EC2. I'll go with Ubuntu, and in Ubuntu I will go with there are two versions of Ubuntu are available, as you can see, but from a StrongSwan compatibility perspective, I would go with 22.04 LTS. It's a bit slow. I will create a new key pair. I will call it use with the TTP, and then create the key pair. And then I will configure the network for it. So basically we'll select the test VPC, and we will put in the gateway subnet, as you can see, and we also enable the auto assign public IP. Now for security rule perspective, this machine needs to have two ports open, which is UDP 500 and UDP 4500 for the IPSec VPN connectivity perspective. So I will call it the security group called Gateway SG, and I'll keep the SSH to allow anywhere. We can actually do SSH from anywhere if you want, but we also have to add another security rule there, and in here we have to say all UDP right? We're allowing all the UDP. You can be more specific. You can go for UDP 500 and UDP 4500 as well, but I'm just going all UDP. And the source should be my IP, because in this demo, I'm going to use my home-based Linux machine to create the IPSec VPN. So I just select my IP, which is my public IP of my home environment, and that's it. I think we're good to go. Let's launch this instance. So we are creating an EC2 instance for StrongSwan or Secure Swan. Sometimes, there are two different words used, basically names for use for this product, StrongSwan or Secure Swan. Essentially, it's a VPN software. So our EC2 instance is up and running, as basically status. So let's wait for the pause for the video for a few minutes till we actually get our EC2 instance up and running, and then we will install the software into it, and then we go from there. So meanwhile, our server in the EC2 in the AWS is about to be up and running. I logged in into my home environment, and as you can see here, I have actually Ubuntu Linux as well on my home environment. This VM is basically behind a home router. Usually in the case of a home environment, you always have a router which gets a public IP from your internet service provider. But the IP address on the VMs which you create inside the home environment does not get a public IP directly. So as you can see on this machine, which is also an Ubuntu machine, it has an IP address of 192.168.68.76. This is the machine we have already installed the StrongSwan. So when you install the StrongSwan on the Ubuntu machine, you will get two important files to configure. Let's go to our etc directory. And if you do ls-al on IPSec star, you will see two important files. One is the IPSec.conf file, and second is the IPSec.secrets file. The IPSec.conf file contains the configuration of your VPN tunnel, and IPSec.secrets file contains the secret or the key which is used for establishing the VPN tunnel. So let's go ahead and check the contents of the two files. So let's start with IPSec.conf file first. Now IPSec.conf file, the main part has been shown here. I mean, as you can see here, I defined a connection called AWS 1, and there are some parameters there which I have to change according to my requirements, or depending upon what AWS environment will give us. So as you can see here, the left ID represents the IP address of my home environment, and the left subnet represents the subnet which is basically behind my public router at home. On the right hand side, I have to put the public IP address of my EC2 instance, which we are going to get it from AWS once it is up and running. And the right hand subnet is a subnet which is basically we have to use on our right hand side, which is the VPC. So we know that this value has to be changed because our VPC is 10.1.0.0, but we have to wait for the public IP configuration of our EC2 instance. So let's go back to our EC2 instance and see the instance is up and running. I think so. Yeah, it's already initialized. Everything is okay. So let's go and check its public IP. So this is its private IP, as you can see, and this is your public IP. So I will actually copy paste this IP, and I will go in the file, sec.conf file, and I am going to change the IP of this public IP of my AWS instance. So this is, we got it. Let's check it again. Yeah, I think we have to put in a space here. Actually, we can remove the space, no problem. We save the file. So this is the ipsec.conf file. The second file which is important is etc ipsec.secret file. Sorry. Yeah, ip.secrets file. So as you can see here, basically in the secret file, you have to put the IP address, the public IP addresses of your tunnel's endpoints. So as you can see here, we have a public IP of our home router, and then we have to put the public IP of our EC2 instance, and then you have to put the key. So what I have to do is I have to update this file as well. And I'm going to put the IP address of my EC2 instance. Sorry. Go back and get my IP address. Remove this one. And we will save the file. So ipsec.secrets file is saved, and we also have updated our ipsec.conf file. So the configuration on our home side of the Linux machine is done. Now we will go back to our EC2 instance and do the same configuration over there as well. So first of all, we have to connect to this instance. So let's connect to this instance, and we can connect to this instance. Yep, we need to connect to this instance. And as you can see on the bottom left corner, you're getting the public IP as well as the private IP of this machine. Okay, so we are going to root on the machine. So this is basically our EC2 instance on which we are going to install StrongSwan. To install the StrongSwan, basically I have prepared all the commands. So essentially we have to execute two commands here. Let's run these two commands. So now we're installing the StrongSwan on the machine. Okay, StrongSwan is done. Then let's check again. Yeah, so StrongSwan is done. Then second thing we have to do is to execute, or we have to actually enable the IP forwarding on this machine, which is a very important step. So let's go ahead and open this file, which is sysctl.conf file. And we have to enable the IP forwarding. After that, we have to refresh our kernel settings. There's some additional steps which we have to do as well if we want to make sure that this setting is permanently enabled. Right now we're just doing it to establish our VPN tunnel. Now what we have to do is to go again to the etc IPSec directory, go to etc and open our first file, ipsec.conf file. And you just have to make sure that it's commented out, and then what we have to do is I can actually have the setting here. So let's copy paste exactly the same which we have on our Linux box. The only difference is we have to make sure that the IP addresses are correct. So as you can see here, this is our right IP in this configuration, which is our public IP address of our public router. This is our public subnet, and here we have to put the IP address of our EC2 instance, which is visible here on our connection. So we'll just copy paste from there. Okay, and then we have to make sure it reflects the right VPC IP addresses. Second thing, what we have to do is update our key file, and that's our file is okay. So on this one, I will go back to my Linux machine, and I will copy paste the contents from there. Now it's very important that the order of the IP address should be accurate. So essentially this one will be our this should need the cloud IP in this case needs to come first, because this is our AWS side. So 3.235.145.20, and I will remove it from here. So this is done. We will save it. We'll go back to our Linux machine, home Linux machine, and we will open it again. Here, as you can see, we have to change the public IP again. So I think we already have done it, most probably. Yeah, just make sure that the settings are accurate. And as you can see here, more etc ipsec.conf and more etc ipsec.secrets. So here, as you can see, we have IP address 3.235.145.20, and on our Linux machine we have the same IP addresses, but just the order is reversed. So essentially that I have to make sure, and also have to make sure that the keys which we have here exactly matches on both sides. So we have done our setup for both the Linux machine. We're ready to start the IPSec services and start the VPN tunnel, try to make it up and running. But make sure, and it's very, very important, that you have to make sure that when you're connecting it from your home lab or from your on-prem location, the two UDP ports, UDP 500 and UDP 4500, has to be open. Otherwise the VPN tunnel will not be up and running. So let's go ahead and start our VPN tunnel for the first time. Okay, so now we are ready to try our IPSec tunnel for the first time. So let's start with stopping first. It's already stopped. Make sure that basically the IPSec tunnel first starts on the AWS instance. So as you can see here, I already have started on my AWS instance. So I'm trying to do now on my Linux machine. So if I started, sometime what happens is that it takes some time. It's not automatically connected, so you have to keep trying 2 or 3 times, and then hopefully it will connect. So as you can see, in my case, it's connected, and the tunnel is up. The session is established, and we have now successfully VPN tunnel up and running between home Linux machine or our home environment and AWS EC2 instance. To verify, I can ping my IP address 10. 1.1.1.114. It's not pinging, and we know why it's not pinging, because we have not allowed the ICMP traffic from anywhere. So let's go back to our EC2 instance, and let's go to the security, and we will add another rule here in the security group. So as you can see here, the UDP connections are there, but and 22 port is there, but we have not added the ICMP from anywhere. So let's go and add our rule for ICMP. So let's go and edit inbound rule. We add another rule, and we say all ICMP version 4, and I think I can allow from anywhere for now, but essentially you can put my IP as well. So let's do that and see what happened. So we applied the security rule. Hopefully it will ping after some time. So let's wait for our security rule to be effective. Try our tunnel is up and running, as you can see here. Let's see the status first. So our tunnel is up. Now, one thing which I did a mistake in the IPSec.conf file on home Linux, that I had actually IP of 10.2.0.0/16 instead of 10.1.0.0/16. So after a little bit troubleshooting, I found out it was not pinging. So I corrected it and then restart the tunnel. The tunnel is again established, and as you can see that we are able to communicate, or we should be able to communicate between home Linux and this VPC subnet, which is 10.1.0.0/16 as per our design. So as you can see here, our subnet was 10.1.0.0/16. So make sure that IPSec.conf file and home Linux is having the right VPC IP address as well. So let's ping now, and as you can see, we are able to ping, and we should be able to SSH as well. So let's try SSH as well, and as you can see, we are able to SSH. So right now, after the VPN tunnel is up and running, we are able to ping, we are able to SSH to the private IP of our EC2 instance, which shows that the tunnel is up and running. Thanks for watching, and in my next video I will show you how to route the traffic, or how to reach out to my DB2 instance or any other home Linux machine which is behind the firewall, but it has to go through the VPN tunnel to reach to the EC2 instance. So let's thanks a lot for watching my video, and I will see you in my next video. Thank you.